Hi class, what I want to do in this lecture here is continue our lecture series on solving trigonometric equations, and this is just our lecture number 6. And what I want to do here is I just want to do 3 examples, just of varying different types of problems, just to kind of like rehash and bring everything to a close here. All right, so here'll be the first one. All right. Let's solve this. So this is, and actually forgive me, we're on example, look at this, we did 20, now we're on example 21. So 3 more examples in this lecture. Let's solve tangent of x is equal to negative 6.21521. Geez, on. And now you have to pay really close attention to this. 0 to 2 pi. Okay. So look, how are you going to do this? Well, you're going to use your inverse function properties. You're going to take tan inverse of tangent of x, because I want to get x by itself, is equal to tan inverse of negative 6.21521. Okay, now here's what's going to happen, okay? You're going to solve this using tan inverse of negative 6.21521. And look what you're going to get. You're going to get a negative number, all right? So I'm going to round this to 4 decimal places. Negative 1.4113, okay? But, I want x to be between 0 and 2 pi. This number is not between 0 and 2 pi. So you have to figure out what's going on here. And so you have to remember that tangent's period is every pi. So if you were to go back and just look at the graph of tangent, right? It's pi over 2, negative pi over 2, 3 pi over 2, and 5 pi over 2. Right, this graph looks like this. So what your calculator just gave you, all right, is this value negative 1.4113 is somewhere over here. So it just gave you this solution. So look, between 0 and 2 pi, there's going to be this one and this one. So really what you're going to have is you're going to take and you're going to add pi to this. So one solution is going to be negative 1.4113 plus pi, which looks weird, so I'm going to write it as pi minus 1.4113. And then another one is going to be minus 1.4113 plus 2 pi, which is 2 pi minus 1.4113. And those are the 2 values between 0 and 2 pi, okay? And suppose, just to show you that this is indeed the case, all right? Watch when you do my calculator here, okay? If I take tangent of pi minus 1.4113, look, it's a little off because I rounded, but you can see it's really close. And then it's the same thing if you do 2 pi. And again, it's slightly different than negative 6.21521 because I rounded this off. That's why. So yeah, you have to pay very close attention to what it's asking you to solve on here. Okay. All right, let's do this one. Let's solve this. Let's look at cosine of x times cosecant of x is equal to 2 cosine of x. And let's solve on 0 to 2 pi. Whew, this is tricky, all right? So what are you going to do? You're going to start by subtracting this cosine over, and you're going to see why. So I have cosine of x times cosecant of x minus 2 cosine of x is equal to 0. All right, well, how are you going to solve this? All right, well, factor out a cosine. Check this out. This is awesome when you do this. Cosine of x times cosecant of x minus 2 is equal to 0. So look what's going on here. You have something times something equals 0. So you either have cosine of x is equal to 0 or cosecant of x minus 2 is equal to 0. Well, this one's pretty straightforward. When does cosine of x equal 0? Well, that's pi over 2 and 3 pi over 2. Here, this is what's going on. You're looking, when does cosecant of x equal 2 now? Well, what is cosecant of x? Well, that's 1 over sine. So when does 1 over sine of x equal 2? Well, flip both sides. You're looking, when does sine of x equal 1/2? Well, let's take a look. That's pi over 6 and 5 pi over 6. So my solutions here, just putting in order, right? So I got pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. All right. We're on our last problem. We made it. Okay, and this is going to be the hardest one we've done. All right. It's going to be multi-stepped here. All right, so let's jump right into this. Our final example. Let's solve sine squared of x minus sine of x minus 1 is equal to 0. And let's solve on 0 to 2 pi. All right, well, first off, the first thing you should do is try to factor. It doesn't factor. There's no trig identity you can sub in here, but you know what? This looks like a quadratic type of form, right? So you can use your quadratic equation here to solve, all right? And what you're gonna, this is important, quadratic equation to solve when sine of x is equal to 0, and that's important, okay? Because that's just going to tell you when does sine of x equal 0, but then we're going to start looking for x. So here my a is 1, my b is -1, and my c is -1. So sine of x, because it's equal to 0, I can do this, is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So -b, that's -1, plus or minus the square root of -1 squared minus 4 times 1 times -1 all over 2 times 1. Well, negative, so that's 1 plus or minus the square root of, well, this is 1, ends up being 1 plus 4, so this is square root of 5 over 2. So you have two solutions, right? You could have sine of x be equal to 1 plus the square root of 5 over 2. And what is 1 plus the square root of 5 over 2? That's roughly, I'm just going to save us a little time here. This is roughly 1.6180. But sine can't be greater than 1, so no solution here. So the other possible solution is that sine of x is equal to 1 minus the square root of 5 over 2. Okay, so look, what is 1 minus the square root of 5 over 2? Again, to save a little bit of time. That's negative 0.6180. All right, so here's what we're doing, just so we're clear what's happening here. I recognize that this was quadratic form, okay? So to figure out when sine of x is equal to 0, I use the quadratic formula, and this is what I got. All right, but now remember, this is only telling me when sine of x is equal to 0. It's when sine of x is equal to this, okay? So I have to get x, right? Or excuse me, this was helping me figure out when the whole thing was equal to 0. Sorry. So to figure out what x is equal to, I have to now use the inverse trig here to figure this out. All right, so I'm going to go to the next slide. Sorry about misspeaking there. So this is what we started with. And we saw that this whole equation equaled 0 when sine of x was equal to 1 minus the square root of 5 over 2. Okay. Or when it was equal to roughly negative 0.6180. So to figure out the value of x here, you're going to take sine inverse of each side. Remember, we're solving on 0 to 2 pi. So we grab our calculator and let's see what x, the value of x is going to be. Well, you got negative 0.6662 roughly, okay? But remember that we want to find the solution on 0 to 2 pi, okay? So you have to go back and you have to use your unit circle here, okay? So this is saying, this is the radian measure. So this is saying a negative 0.662 is when sine is equal to roughly this, okay? But like, remember, it's repeating itself, okay? So there's two different values here, okay? So one would be starting at 2 pi and subtracting this. So one solution, x is equal to 2 pi minus this value. And then another one here would be pi, but then adding this value. And this is where, this is where things get a little confusing, okay? And that's why you have to pay attention to this. And remember, when is sine negative? It's in the third and fourth quadrant, and use that to help you get the actual exact answers. All right, class, I know this last one was tough and it was confusing, but you will get a chance to practice this, and just always remember the properties that you've been taught, and I know you can all do this. And if you have any questions, as always, I'm here to help.